So the first law we are going to investigate now is known as Boyle's Law, named after the English chemist Robert Boyle. According to Boyle's Law, pressure and volume are inversely related. What does that mean? That means if you have a gas at a certain pressure and a certain volume, if the pressure goes up, then the volume must come down, or if the pressure goes down, the volume must go up, as long as you keep the temperature and the number of moles constant. So remember when we looked at an earlier video, there are four variables that we are going to pay attention to when it comes to gases. They are pressure, temperature, volume, and number of moles. Boyle's law relates pressure and volume, while we must keep the number of moles and temperature constant. But what does it mean to keep it constant? It means in the case of number of moles, it means you don't allow the gas to escape. Let's say you have it in a balloon. You don't allow it to escape, nor do you allow more to enter inside. If it's in some cylinder, you don't allow it to escape, or you don't allow more to enter in. If that's the case, the number of moles of gas is constant. At the same time, do not heat your gas or allow it to cool down. Keep the temperature constant. If those two conditions are met, now if you increase the pressure on the gas, volume must go down. Or if you decrease the volume, pressure has gone up. Either way you can think of it. At the same time, if the volume goes up, pressure must come down, or if the volume goes down, pressure must go up. Now, the Robert Boyle's law, known as just simply as Boyle's law, is described through an equation as P times V equals Kb. Kb is a constant. It may look sophisticated, but it's just a constant, and a constant is just a number. What's a constant? It's some value that remains the same. That's what it means. Pressure times volume of any gas at a given temperature and number of moles, whatever it evaluates to. Now, even if you change the volume, pressure will change. But when you multiply them out, it should still be the same number. So another way of stating this equation is pressure I, initial pressure, times volume I, initial volume, must equal to pressure final times volume final. What does that mean? That because P times V is a constant, whatever is the value here, the product of initial pressure and volume must equal to the product of final pressure and final volume. Here in a cylinder you have an example. So here are these molecules you see floating in air. We have exactly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. And in each of them there are 10 of them, meaning that we are not allowing the number of moles to change. Also, we are keeping the temperature constant. Notice it says 298 Kelvin. And remember, temperature is measured only in Kelvin when it comes to gas laws, when it comes to studying gases. So now, as we apply more pressure on the piston, from 1 atmosphere, the gas inside starts to exert more pressure. Originally, it was occupying 10 liters, and when you multiply this pressure, 1 atmosphere times 10 liters, you get a value of 1 times 10 equals 10. Yep. So 10, and the units would be liters times atmosphere. Down here you can see liter times atmosphere. But then when we increase the pressure to 2 atmosphere, notice what happens to the volume. Volume goes down exactly by 5 liters to a new volume Vf of 5 liters. So now when you multiply 2 atmosphere times 5 liters, you still get 10 liter atmosphere. What if you keep on increasing the pressure and now you apply enough pressure that the gas inside fills 4 atmosphere? Also, who exactly is applying the pressure? It's both ways. You are applying a force times this area, force divided by this area, which equals to 4 atmosphere, and the gas itself is exerting 4 atmosphere of pressure on the wall. If it was exerting more pressure than 4 atmosphere, then your hand would be forced to move up. Or if it was exerting less than 4 atmosphere, you would still end up pushing the piston more. So there is a pressure of 4 atmosphere inside, and the volume now is 2.5 liters. When you multiply 4 atmosphere times 2.5 liters, you still get 10 liter dot atmosphere. So you see how pressure times volume evaluates to a constant. In this case, it was 10 liter dot atmosphere. Here is a problem. So basically it's the same problem as we looked at in the previous slide example. A gas occupies 10 liters at 1 atmosphere. If the pressure was doubled to 2 atmosphere, what would be the new volume? How do you solve this? Well, you write it down as Pi times Vi equals Pf times Vf. That's the form of the Boyle's law that you should understand to solve this problem. Now look at the problem and see what you are solving for. Are you solving for pressure or volume? The answer is you are solving for volume. But are you solving for initial volume or final volume? You are solving for the final volume. So you must rearrange this equation where you isolate the final volume on one side and keep everything else on the other side. What you will do is divide both sides of this equation by PF. When you do that, you cancel out the PF term here, moving it here, and so Pi times Vi over PF equals Vf. Then you just plug in the numbers and solve to the right number of significant figures, which gives you 5.0 liters. Here are more problems to practice. A 5.0 liter sample of a gas at 25 degrees Celsius and 3.0 atmosphere is compressed at constant temperature to a volume of 1.0 liter. What is the new pressure? Okay, so now here you are finding PF, not VF. And then the next question, a 3.5 liter sample of a gas at 1.0 atmosphere is expanded at constant temperature until the pressure is 0.10 atmosphere. What is the volume of the gas? So here you are finding Vf. Also, whenever you are studying gases, there are many equations involved with gases. Which one to use? So far we are only looking at this one, the first one, but we can find out which is the right equation by seeing what is being kept constant. And you are told what is being kept constant. So you are being told temperature is kept constant. And unless you are told that new gas enters or exits, you must assume that also the number of moles of gas is also constant. So N is constant and T is constant, which tells you you must use the Boyle's law equation, which says Pi times Vi equals Pf times Vf.